Now, concavity of entropy, another approach. So basically, h of p is a concave function of a distribution Tx. This means that if you mix distributions, the entropy increases. We can show this by playing with random variables. So let's let x1 be random variable with the distribution p1x, x2 with the p2x. And let z be x of theta, where theta is 1 with the probability lambda, 2 with the probability 1 minus lambda. Thus, the distribution of z is equal to lambda px p1x plus 1 minus p2x. How do you get this? Basically, you can use the total probability theorem to get this. So once you have found the distribution of z to be this one, then we can show entropy of z. Okay, entropy of z is the entropy of this distribution, and the entropy of z given theta. So entropy of z given theta can be written as this one right here, right? Because you can write this. Let's say, hold on a sec. Let me open up this one. Okay, so this part can be written as entropy of z given theta is equal to 1, and the probability that theta is equal to 1 plus probability that theta is equal to 2 times entropy of z given theta is equal to 2. So that is nothing but this part right here. Okay, and the entropy of distribution of z is given right here. Since h, which is the entropy function, entropy is a concave function. Concave function goes this way, so a function of average is greater than average of function, which is right here. Okay, so average of function of average, inequality goes this way, because entropy is a concave function of input. So concavity of entropy has been proved again using this random variable z. Hold on a sec. Now we want to talk about concavity. I'm sorry about that. Capacity of I, x, and y. I'm so sorry. Concavity of mutual information between x and y over px given py given x. What do we mean by this? We are fixing the conditional distribution py given x. This is, you can treat it like a fixed number. This one is given, and then you are having px as a variable. So mutual information between x and y is a function with these two, but since this one is fixed to be a number, then you are having px as variables only. So this is a function of px only, given this statement. So we can talk about concavity or convexity of this function over input px, given the other fixed. So that's the problem. And then this can be shown to be concave. So using this definition, h of y is a concave function. What about this one? That one is nothing but this. And here, this one is a variable. Okay. Given a particular value, and then entropy on y is a function based on this, which is fixed numbers. So this one is a fixed numbers as well. So you can treat this as a linear function of px. So the mutual information is a concave function with a summation of linear function of px. So what is this whole thing in terms of px? It is a linear and concave over px. So it's a linear term and a concave term added together. So what is this function with respect to px? It is a concave function because of the first one. So that's the hint how you can approach to prove that mutual information given p, y given x is a concave function over px. But that is informal proof. If you want to prove exactly what do you need to do, you have to use Jensen's inequality, right? So how do you use Jensen's inequality? What is the problem that you have to solve? That problem, in order to solve that problem, you need to define the two problems. So for example, P1x, because this is about Px as input, so you consider two distributions, P1x and P2x. And then you want to consider the x average of distribution, right? So lambda P1x plus 1 minus lambda P2x. So this is what? Average distribution. Okay. So this in Jensen's inequality, the whole thing plays the role of x1, x2, but each one of them is a vector because it's a distribution. So you are talking about a vector point and a vector point, two vector points, and then average of the two vector points, and that's what this vector is. So that's average the vector point. Okay. And then you need to consider mutual information of each individual ones. So let's say we call it mutual information based on P1x. We can call it mutual information between x and y based on P1x, and then we multiply that with lambda plus 1 minus lambda mutual information using P2x. We call it I2 x and y. And then another one based on lambda, P lambda x, right? So that's, and then in order to show concavity, average, so concave function of average should be greater, so this goes that way. Okay, we need to show this. So that's the formal, rigorous way to prove concavity of mutual information over Px given Py given x. I'll give you a note about how to prove this. Okay, the formal way. All right. Please find the note in the talk room. I will send it in the talk room. So here is the sequence of results so far. So relative entropy is non-negative, has been proved. And relative entropy is 0 if and only if the two distributions are identical, proved. Entropy h of x is maximum if x is uniform distribution. Mutual information is a relative entropy, and the mutual information is a relative entropy between joint distribution and the product distribution. And then based on this statement right here, the product distribution should be equal to joint distribution when the mutual information is equal to 0. So when the input and output are independent, that is the case when the joint distribution is equal to the product distribution, the mutual information is equal to 0. And also by the use of relative entropy, again, mutual information is non-negative. And as I told you, mutual information is 0 if and only if input and the input and output, or the first and second, are independent. Then using this definition, we can show that conditioning reduces entropy. And using the concavity of relative entropy, entropy is a function of distribution, a concave function of distribution. And the mutual information is also a concave function of Px given Py given x. This result will be different if we talk about something else. For example, mutual information between x and y may not be a concave function of Py given x given Px. So we can talk about something different if we switch the role between Py if we switch the role of fixing. So if we fix px to be fixed, and then mutual information as a function of py given x, we may come up with different result.